Well, in this example, we'll see the use of recommendations inside your spark.ml library, and we'll use specifically the ALS algorithm, the alternating list square algorithm, for recommending movies from our movie ML 100K dataset. Okay, and we'll see how it performs and how the recommendations are from qualitative point of view. Will not measure in from objective point of view because it is quite uh, obvious for this kind of data sets for recommendation. And so for that we have set up a fake persona here, so with user ID of 0. So in the entire data set there is no user ID with 0, so we have used this user ID with 0, and we have added these 3 rows inside this u.data, okay, for setting up the user persona. Okay, and from this persona we will try to predict, or we will try to recommend some movies for this user. Okay, so let's go through the columns here. So user ID 0 rated 50 movie 5 star, 172 movie 5 stars. So essentially these two movies are Star Wars episode 4 and 5, and he or she rated 133 movie as 1 star. That means this guy loves science fiction but does not like romantic dramas. Okay, so essentially 133 is Gone with Wind, and he or she does not like it. So let's see what our ALS engine in our SparkML library gives recommendation for this user. And from the code point of view, this is quite simple and quite easy to use, though alternating list square is not that easy algorithm. Actually, there are complicated mathematics behind it, but we'll see how we are going to use that. So for that, we have imported all the packages here, necessary packages. More important is that ML recommendation under that everything, and we have set up the object here, and for this object we have just created two case classes for the two data set we will be using for the names in the u.item and for the data from the u.data. So movie ID and movie title we can get from the movie names, and ratings we will get from user ID, movie ID, and rating. Timestamp we do not need, and from the movie names we do not need other things. So these movie names is just to look up for the IDs which have been recommended by this engine. So for this we'll use this movie names case class. Well, inside the main function, okay, we have set up the log levels, set up the Spark session, and so we are just now loading the movie names from the schema called movie names schema, and movie schema for the ratings. Okay, so again these are the implicit types, and here we are reading the two files. Okay, one is the u.item file and u.data. So yeah, we have modified u.data just to uh, specify here because we want to find the recommendations for 0 user ID. Okay. So as usual, the pipe characters was the separator for the u.item, and tab was the delimiter for the u.data. So you are using that, and then for the options schema, we are using both this movie schema and movie name schema. Well, after that, we have to set up the model. So new ALS model we are creating with these hyperparameters. Now for these hyperparameters, the dirty little trick is that you try and test which parameter is suitable for you. Here I'm using 5 and 0.01 after several trial and error, but we can check with that. Okay, so and you need to specify to this algorithm that which are the user column, item column, and rating column from the data frame. So these are the user ID, movie ID, and ratings we are using from that schema. Okay. So now we need to train that model with this ratings data set we have created. Okay, and after that we have to gather the recommendation for the user ID. So we are giving the user ID from the command line argument, and the argument 0 as 0 we will be giving that we will see next. But for this user ID, okay, whatever user ID we have set up or user ID we have given, we are just uh, extracting the user ID. I mean, we are just extracting the user ID depending on that user ID data from the data frame. And after that, we have just uh, extracted or got the subset as the users, which is the user. So here you can essentially use multiple users as well. So you can get recommendations for multiple users, but here I'm using only for single user here, which is given from this argument. And after that, you need to define how much uh, uh, recommendations you want. So first 10 recommendation we want, and then we are just printing out the values. But this is the hardest part where you have to actually uh, uh, get or extract those movies from these recommendations. So for each recommendation, we are just extracting this inside your temporary variable. But here, this array, you need to actually explicitly tell Scala what it is. So so this is a wrapped array row, and that is mutable in nature. So that you need to actually explicitly mention and typecast to this recommendations to get the values in Scala. Okay, so we are just getting that temp and then iterating through that temp to get all the recommendations and giving the output as movie rating and movie name. Okay, so let's and to get the name, okay, get movie name is the little function in Scala we have set up. That is just taking these movie names to look up this and filter out the movie with the movie ID whichever we have set up, and the result will be the title which will be the written from this movie names. Okay, movie name. This is the Scala method. So essentially, this name list which we are taking is from the names we have collected into the driver script. So basically, there are not many names are there, so you can just keep it into driver script and look up later. That's what exactly we are doing that. So we are not doing the lookup inside the Spark, but rather we are doing that in Scala. Okay, so we are collecting from that data set, and then we are keeping that list to look up this movie name from the ID. Okay, inside the Scala or inside the driver script, rather. So let's run it. But before that, we need to set up the argument here. So for that, you need to edit movie recommendation ALS, and you can give the argument as 0. Okay, program argument you can give, and then you hit the run. So let's see what kind of recommendations we have got for user 0, who loves science fiction but does not love or did not give ratings well for romantic movies. Well, from the first 10 recommendations for user ID 10, uh, you will see this endless summer, Balto, uh, to be or not to be. I think these are not science fiction movies. Traveler, Lost in Space, those are okay. Transformers are okay. Yeah, In the Mouth of Madness, of course, this is not okay because this is a romantic movie. So as you can see, you are getting mixed results from this recommendation engine, and that's mostly because the data set might be smaller, or the hyperparameters might not be suitable for this kind of approach. So you can use trial and error method or test train method to actually see what kind of parameters are best suited for this data set, and do some experiments. But as far as I have seen that this is not working properly for this data set, might be because of the length of the data set is not too much, and a very simple similarity matrix from the movie IDs or movie set is working better for the recommendation, as I have seen. So that is kind of much simpler approach. If you would like to see, I can actually give you an session for that. But anyway, for this complex ALS algorithm, this is not working properly. As you can see, there are some mixed results. So well, it is not exactly these black boxes will work properly for your approach. You need to check, and you need to actually be sure about these hyperparameters. They are working fine for your data set. So it's not kind of thing that you will use go-to method. Okay, so anyway, that we have seen the use of extracting the job towards data set and use that throughout the entire cluster. That is good. Uh, so linear regression previously worked better than this one. So well, we'll see in our exercise another one, but the recommended or suggested thing is that you need to actually test and train, or you need to actually explore how the methods are working well or not. So it is not that you can directly use and use default parameters as your go-to thing. So this is kind of um, not recommended that it will work every time properly. Okay. So with that, we'll jump towards our next session of exercise, and we'll see in the assignment.